Hello, today my team and I will be performing video presentation according to our topic, which is gas law in engineering, medicine and the environment. Assalamualaikum and hello, my name is Nur Afza Ilyana binti Ibrahim, student ID 2025869344 and I'm from group AS1201I. The subtopic I will be presenting is gas law and main gas law. So, what are gas law? Gas law are scientific rules that describe the behavior of gases under different conditions. Gas law show the relationship between first, pressure, which is force of gas on container walls, second, volume, which is space occupied by the gas, third one, temperature, which is measure of heat, and the last one is amount of gas, which is a number of gas molecules. So basically, gas law explains what happens to a gas when we compress it, heat it, cool it, or change the amount of gas. The next subtopic is main gas law. Main gas law divided by 5, which is Boyle's law, Charles' law, Gay-Lussac law, Avogadro's law, and ideal gas law. So first one, Boyle's law. Boyle's law explains at a constant temperature, the pressure of fixed amount of gas is inversely proportional to the volume of gas. Next is Charles' law. Charles' law explains the volume of a fixed amount of gas maintained at a constant pressure is directly proportional to the absolute temperature of the gas. The third one is Gay-Lussac law. Gay-Lussac law states that a fixed mass of gas at constant volume, the pressure of the gas is directly proportional to its absolute temperature. Besides that, Avogadro's law explains at a constant pressure and temperature, the volume of gas is directly proportional to the number of moles of the gas present. And the last one is ideal gas law. Ideal gas law states that the pressure, volume, number of moles, and absolute temperature are linked together. This law combines of all the gas law, which is Boyle's law, Charles' law, Gay-Lussac law, to describe the behavior of the ideal gases under different conditions.
Assalamualaikum and hi. My name is Nur Umairah Damia binti Muhammad Hamizun and my ID student number is 205206-936. I am from group AS1201I and our group topics is gas laws in engineering, medicine, and the environment. So I'm going to focus on the subtopic, which is gas in engineering. For the introduction, gas plays an important role in engineering because it is widely used as a working medium, energy source, and processing material in many engineering fields. In mechanical and chemical engineering, gases such as air, oxygen, nitrogen, and hydrogen are used in engines, combustion systems, refrigeration, and chemical reactions. In civil and environmental engineering, gases are involved in ventilation systems, air quality control, and pollution management. Gases are also essential in electrical and electronic engineering, for example as insulating media in high voltage equipment and as carrier gases in semiconductor manufacturing. Understanding the behavior of gases such as pressure, temperature, and flow is crucial for designing safe, efficient, and reliable engineering systems.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Wahida binti Hasizi and my student ID is 2025860938. So today I would like to talk and share about the example of gas in engineering. Okay, first of all, the example of gas in engineering is chemical engineering. Why chemical engineering? It is because gas are raw materials in industrial chemical processes. For example, nitrogen and hydrogen gas used to produce ammonia in fertilizer plants. Second is civil engineering. Why civil engineering is it? Because gases are important in ventilation and air conditioning system to control air quality and temperature in buildings. For example, airflow design in HVAC system. Last but not least is aerospace engineering. Why aerospace engineering? Because gases are used for propulsion and control in aircraft and rockets. For example, exhaust gas producing through in jet engines.
Assalamualaikum and hi everyone. My name is Arfa Alia binti Zuki and my student ID 2025283284. I'm from Group ES1201I. Under the topic Case Law in Engineering, Medicine and Environment, I will focus on gas law in medicine. Although many gas laws exist, Boyle's law, Henry law, and Dalton law are the most commonly applied in medicine because they are directly related to respiration and gas exchange. Now, let's start with Boyle's law. In medicine, this law explains how breathing occurs in the human body. When we inhale, the lung expand and causing the volume of the lung increase and the pressure inside the lung to decrease. This lower pressure allows air to enter the lungs. During exhalation, the lung volume decreases and pressure increases, and air push out. Boyle's law is also applied in medical syringe. Pulling the syringe longer increases the volume inside the syringe, lowering the pressure and allowing the fluid to be drawn in. In hospital, this law is important in the design of ventilator, which help patients breathe by controlling pressure and volume change in the lungs. Next, we will discuss about Henry law. It explains that the amount of gas dissolved in a liquid is directly proportional to its pressure. In medicine, it explains how oxygen dissolves into the blood. In the lungs, oxygen enters the blood because of the partial pressure of oxygen that the alveoli is higher than in the blood. It allows oxygen to dissolve efficiently. Henry law is applied in oxygen therapy where increasing the pressure and concentration of oxygen helps more oxygen dissolve into the patient's blood. This is especially important for patients with respiratory disease or low oxygen level. The law also explains medical conditions such as gas embolism and decompression sickness, which can occur when gas comes out of solution too quickly due to the sudden pressure change. Last but not least, let's look at the Dalton in medicine. Dalton law states that the pressure of gas mixture is the sum of partial pressure of each individual gas. In medicine, this law explains how different gases in air contribute breathing. Oxygen, nitrogen, and carbon dioxide each exert their own partial pressure, and oxygen uptake depends on its pressure. It applies oxygen mask, ventilator, and anesthesia machine where doctor can adjust oxygen level to ensure patients receive the right amount of oxygen during treatment or surgery. It also helps understand gas exchange in the lungs.
My name is Siti Aisyah binti Muhammad Zaidi. My student ID is 2025 884576, and I'm from ES1201I. The topic that I would like to discuss is the gas law in the environment. Gas law in the environment is very essential for understanding and predict the atmospheric behavior, weather patterns, and climate change. As we know, gas law have 4 laws, which is Boyle's law, Charles law, Gay-Lussac law, and ideal gas law. Boyle's law can be defined in the environment as a When at constant temperature, pressure is inversely proportional to volume. Charles' law can be defined as when at constant pressure, volume is directly proportional to temperature. On the other hand, Gay-Lussac law can be defined as when at constant volume, pressure is proportional to temperature. And the last one is ideal gas law, which is ideal gas law is the combination of all gas law that in one equation. The equation is PV equals nRT. Let's go to the next slide. In this slide, I want to talk about the climate effect. The first one is Boyle's law. Boyle's law is make the air rises and makes the pressure decrease and the air expands. Expanding air cools, leading to cloud formation and the rain. Boyle's law is very important in convection, storms and monsoon systems. The second one is Charles' law. In this law, when the warm air expands and less dense, warm air rises, it causes wind and air circulation. Charles' law is used for explain sea breeze and global wind patterns. Gay-Lussac law is when air on Earth's surface heats up, air pressure changes. When the air pressure changes, it creates low pressure systems which control weather patterns. One is ideal gas law. Ideal gas law is talk about greenhouse gases behave as temperature increase. When the temperature increases, gas expand and alter atmospheric circulation. It would be affect rainfall patterns, heat wave and storm intensity. That's all from me. Thanks for hearing.
Hi, Assalamualaikum. My name is Nur Nadira binti Muhammad Sazali and my student ID is 2025214116 and I am from Group AS1201I. So, after learning about the application of gas laws in engineering, medicine and environmental fields, we can conclude that all these areas are connected through the same basic gas principles. Gas laws such as Boyle's laws, Charles' laws, and even the ideal gas law explain how gases behave when there are changes in pressure, volume, and temperature. Although the applications are different, the scientific principles behind them remain the same. In engineering, gas laws are important in designing systems that involve pressure and gas flow, such as engines, pipelines, and air conditioning systems. Engineers rely on these laws to ensure safety and efficiency in their designs. Next, in medicine, gas laws help explain breathing mechanisms and the use of medical equipment such as oxygen tanks and ventilators. Understanding gas behaviors is essential to ensure the patients receive the correct amount of oxygen safely. Last but not least, in environmental studies, gas laws are applied to understand atmospheric behavior, weather changes, and the movement of air pollutants. These laws help scientists analyze environmental conditions more accurately. To conclude, gas laws are not only theoretical concepts learned in chemistry, but they play a vital role in real-life applications across various fields. A strong understanding of gas laws is essential to support technological development, medical safety, and environmental protection. That is all for our group presentation. Thank you for listening. Bye!